industry software in India. He has been with Siemens for the past 16 years, and he has totally 29 years of experience. So he's a real veteran in the industry. He has almost 22 years experience in software, sales, as well as development. And over the past 7 years, his expertise in the manufacturing domain, and he is contributing individually as well as in managed roles. And his current role in Siemens, he is helping the maritime industry in India to adopt the Siemens ship solutions. And he holds a post-diploma in tool engineering. So with this introduction, I may invite Mr. Manoj Singh to start the presentation. Over to you, Mr. Manoj.
Thank you, sir, for the introduction. And let me quickly start with the presentation. So I'm sharing my screen. Just any confirmation? Can you see my presentation? Hello.
Yes, we can see that.
Okay.
So you have moved on.
Yes, I will switch off my video for the bandwidth benefit, and then at the end I will switch on. Okay. So digitalization and industry 4.0, these two words we are listening, but they are almost same. It's not that digital journey of the industry has started today, right? We all understand we are using so many software for last 30 years, but these softwares are applied in a silos. So there are design solution, there are planning solution, there is Excel sheet, and there is some other solutions. But the time has come where industry think that if they have to become more efficient, they have to leverage this data by connecting them. So if I have certain object in my design, I should know that what is that item if it is in my ERP system. So they should be matching, that they should be traceable, so that I can find out what is the procurement status. If I have a manufacturing execution system, the same object should be traceable in that system, so that I can find out what is the current state, manufacturing state of the job. So that digitalization is basically bringing all this together, and that's the industry 4.0. So we'll have a quick introduction, because digital twin, there's many ideas in the, because it's evolving. So there are many ideas. So I will just try to explain with my experience. So we start with the simple equipment. So even our ship has, it's basically a floating plant which has many equipment. So just to relate the concept, I'm using this one of the equipment. Okay, so this is a physical equipment, and we have seen this on all these ships. So what this physical system has? So basically, it has a machine which has a control logic. There may be some automation pieces. There are human machine interfaces. There are sensors, edge device, edge apps. I will come to this edge device, edge apps, because this may be two new terms which is related to sensors. So this is the our physical machine today consists of. Okay, we put sensors so that we gather the data. The very simple one can be a vibration data or temperature data or alignment data. There are different kind of sensors are available for catering to different requirements. The sensors, when captures the data, so data need to be processed, right? Otherwise, there is no benefit of capturing this data, right? So there is a term where I can collect this data through sensors, and there is a cloud concept. So I can collect that through some device and stream it to the cloud, where a lot of apps are sitting, which will analyze this data, okay, and give me more insight into my equipment. But now the thing has come, okay, I will get the trends, but suppose I want to make use of this data and take certain critical decision near to the machine, maybe on the machine itself. So I will just use my pointer. So you can see this is the edge device in this particular equipment. Okay, so it's a data streaming and edge device sitting here. So that there are some, so you identify, now you identify your decisions. The some decision critical to machine should be near to the machine. some data will be used for the trend. Suppose same equipment I have on a 5 ship. I will collect from all the 5 ship and mark those equipment performance to find out the trend and take the corrective actions. So here, some decision you have to take here. So you have some computing device you have to have here, on which you can select data which should be less in size, because you can't put a mainframe or big computer here. So it has to. So you have to balance between computing power. Based on computer power and KPI, you decide how much data you will collect and what kind of decision you will take there. So this is like sometime when people talk about a digital twin, they only talk about this, which is you can say it is a data twin. Okay, so it's a twin created out of the data which is produced by the equipment. Similarly, same equipments, right? Same equipment, I will, as a manufacturer, as a shipyard, I may also using many machines like crane, other. So the same technology I can apply there. That is the one part of it. Okay. The second part is, if I have this 3D model available, so there are 3D planning tools available. We call it virtual planning. Okay. So you can do the process simulate. You can see that whether the reachability is enough or the posture is good enough. With this posture, how many machine he can do, and then there should be rest for a worker, because there is a fatigue. In our case, you can say a welding posture of a operator is difficult because of the nature of the compartment or the welding in that particular area, or there is not enough exhaust available, because so you have to plan, like after every half an hour he has to come out. You have, so all those kind of process simulate also you can do in the. So this is basically your so this is data twin, this is your manufacturing twin. Okay, and the last is basically my design twin, engineering twin you can call it. Okay, so engineering twin is because today we are not talking about 3D static models. Now these models are mimicking the behavior of actual machine. How they could do this? So they do this by leveraging the different kind of simulations. So now simulation softwares, they have become very strong. They have become faster. And then you also have there is a possibility to run multi-physics together to understand. So instead of running the physics solution in isolations, now you can run them together like a real-time environment. So now these are not static, they are basically becoming a dynamic, they're capturing the dynamic behavior. So overall, if you say the bottom part where we are talking about machine and capturing data from machine, it is all about operational twin. Okay, it is operational twin. The data which you collect on cloud and the process, this is called information twin. And your virtual planning and rest of the thing is basically your engineering twin. So now twins also have a variety. So you can see there are now many people are talking that digital twin only from data doesn't help, because it gives the behavior of the current system. But if I have to do what if analysis, the simple case I will tell you, suppose you have a system and particular pump is now gone bad, and you don't have an exact repair replacement in your stores, because our vessels are for 40, designed for 40 years, 50 years. And over the time, things have changed. Now I have to see that some other market, which is some other pump, which is close to this spec. If I put that into my system, how it will behave. The data twin has a problem there. So then engineering twin come into picture. Since you have an engineering twin available, you can replace that pump. You put this pump, put all the behavior which is given as a spec by the supplier, and then you put inside your system and solve complete system and see what will be my performance envelope after putting this pump. And with that, you can put a new SOP for your operation team. So that is the way the engineering twin role is increasing now into a digital twin spec. I hope I tried my best to explain this thing, and then I will take some of this engineering twin pieces and operational twin pieces and IT in the subsequent slide to give you more insight into it. Okay. So once it comes to Siemens, so we see the whole digitalization game is based on collaboration. If you don't have a collaboration platform, we are digitalized today as well. So first thing is the collaboration platform, which we bring in, on which all the tools which is used for virtual products. So it can be a design tool, it will be a 3D model, it will be a 1D simulation tool. I will highlight 1D simulation tool in a couple of slides, maybe CFD, structure analysis. So all this thing will go as an input for your virtual production. Then since I'm running this complete thing in virtual production, there are certain observations which can be sent back for verification and new specs can be released. This is all into virtual world. So I'm not still invested in my physical thing. So till the time I'm in virtual environment, I can do the changes with less cost. Then once it is proven, it goes to real production. Again, there may be some issues, validations, and then I have to give the new commissioning process. And at the result of this, with real production, I'm basically delivering my actual product to the industry. And this product will also have certain technology which I have used in real production, like AI, ML, and these things, because finally the solution is from womb to tomb, which is most commonly used now. And so on this, I will have this data highway. It's giving me a closed loop environment. So that this is the vision. Let's decode each area. Okay. So when I say collaboration platform, so there are different, this is just a suggestive list of solutions. So document management, these things we already know, program management is there, data management. Material management is basically, now many of you may be knowing that I use the term womb to tomb. So when it is going for scrapping, you should know how to handle this material. What kind of hazardous material was used at the time of construction. So that information throughout the life cycle you have to maintain, and that also you can maintain on this collaboration platform. So it gives more control on the program and visibility and collaboration. So post that, virtual production comes into picture, where we all know that ships and marine vessels are very complicated. They have by nature, by beginning, because they have a multi-domain engineering. So it has, and those domains are increasing. So it's a mechanical, electrical, electronic, software, all hydraulic, pneumatics. So there's so many kind of systems they are there. Okay. So all this will sit on this collaboration platform, because they are not isolated. The need is to connect them. Okay. So how a typical process works in design that I have tried to capture here. So it starts with basically requirement. So this collaboration platform gives you a way of managing your requirement, because your requirement goes through so many iterations during the concept design and the basic design level, that for complex program, it really become a tedious to find out when change, what change, and why changed. So all this can be maintained here. From requirement, our experts work on the system breakdown. So now there's a tool to create the system breakdown, and there's a tight integration between requirement and system. Tomorrow, if your requirement is changing, you can trace out which particular system will get impacted, or multiple system will get impacted because of this requirement change. That's the value. So we are moving from manual process, so there is a tool to take care of it. Once my system elements are finalized, I have to size them, right? So system engineering, here we use a tool which I will touch upon a little in detail because it is interesting. It is called 1D simulation tool. Okay, because our systems are, as I mentioned, it is multi-domain. It has all kind of engineering here. So we want a tool even before investing in 3D, because 3D is the luxury. At the basic design level, I have very few information. Concept level, even fewer information. So how to leverage technology to have better bidding, to win the bid, we have to be accurate in technical, because so that we can estimate things accurately. So, and once my system engineering is done, where I have done all my parameter sizing, I can take that into a different 1D development solutions, like piping schematic can be developed. electrical schematic, and the concept level design of a ship. So I will talk about it. And then all these things travel into a detailed design, because finally we have to create the hybrid bomb composites, where all this thing, outfitting, structures, piping, electrical, everything is coming together. And as you build more realistic 3D data, parallelly, like you can have a magnetic field interference analysis. Structural analysis is very common, industries using CFD. Probably I can do certain testing virtual. So this platform, like because the typical problem is when I have a system which is having a 10 component, 2 may be internally designed, 8 is I have to source from the market, but their receival at the shipyard at the different time. So when I'm receiving at the factory, I only test that equipment. But the most of the problem comes when you're integrating this thing together. So virtual testing, what I can do is 9 component can be virtual and 1 component can be actual. I can put all the sensors and I can do this hybrid testing, so that I'm testing the individual equipment as well as I'm maintaining the testing of this at the system level. So that is a kind of technologies which I can apply, and all these are basically connected through a digital threads. Every asset is traceable right from, so from requirement I can see, okay, which system is getting modified, whether parameter sizing for that I have to do redo, where it got consumed. From this consumption I can check, okay, this is on which analysis I have to rerun and validate that behavior. So it's a complete traceability which you get out of this. Okay, so one small case I'm just taking. So this 1D system, we have a tool called MSM, where you have a physics model, and we have a library of all this. So I can have a basic resistance model of the ship. I can have a propeller, transmission, and this is a mission profile. Okay, so very detailed engineering is there. I will give you a couple of glimpses of couple of them. So this is a mission profile. So any testing, they have certain mission, right? So I just go full throttle and then I will little bit come down and stable. This is the my mission which I want to run. Okay, this is basically your control system. What plan you have to test. So based on that, you will decide your mission. Then today, as I mentioned, I don't have any 3D model. But there are certain physics model available, like statistical Barras method, where I just give the tonnage and the length between the perpendiculars, and it can give him fairly good result. Or if I have a more data, I can go for experimental data. So ITTC 78 model out of box we have available in our tool. Or if I have a more information, the Holtrop and Menon model, where I can define bulbous bow. All these details depending on where I am. Okay, depending how much information I have without 3D, I can put that and I can use them for solving. And whatever method I use, it's not that the method, like if you see this blue one is the Barras method, it's not very off, it is quite close. So with minimal information also I can do the sizing of other components which is required for my vessel. Similarly, for propeller, I can create a virtual disk, or I can create a Wagon B series based model, or I can create the performance based model based on if I have all the coefficient values available with myself. Okay, if suppose this is not there and I have actual propeller test data available, and it is same propeller which I'm going to use for my next ship, I can even take that tabular performance or graph as a performance propeller model. So it's a very flexible tool. So it gives you and same way engine. So you can define very detailed engine in this with complete mathematical model of that. Okay, and with this I am putting everything together, connecting them. So there may be some, see, this is a mechanical system transmission. These are all signals. There may be some hydraulic. So I am showing you one example, but you can build any kind of system in this tool. And with this, what you can do, you can size your components. So that's the value we add. So what happened is you have solved that, and with that, then you create your hull surface, right? Now this hull surface can be parametric. And this parametric hull surface for the parameters which you want to play with. Today, these things are done by our experienced naval architect. But this is purely based on their experience. But these are the tools which will help naval architecture to try more options. Okay, so I can try that with different models. So with one model, I'm creating options of hundreds of options, and I can plot them against the constraints. So we have a optimization engine called heats. What it does is we have a one thing is I want to make it clear. So Siemens, all solutions are open solutions, but I'm using all internal solution here for designing. I'm using NX. Star CCM is Siemens solution, and then this is heat is also. But if you have some other solutions, even those can be integrated. So our optimization tool integrates 128 tools. Okay, so that's it. So there's a model which is getting modified, which is taken into Star CCM and the validation, and then it is plotted. So with this, you have more options to choose from the optimum design. Best design you can't choose because there are so many constraints you have to balance. So this is the one example in the design domain, how this connected technology is giving you more value out of the system. Okay. So next example, I will take the virtual production. So basically, this is one area where some of the big shipyards have taken max lead. So there are so many things which we do today as Excel sheet or ad hoc process. So there is a process because by experience you have gained the knowledge, and based on those knowledge, SOPs has been created and the systems process has created. But how we can use the technology here. So in one slide, I will try to explain. So it needs three input. One is my digital twin, my ERP, because all this material sourcing is there in the ERP, and that's very important for planning. And there is a concept of virtual shop. So I am showing you the production scenario, but the same tool is also used for capacity planning. If I am bidding for a project and I am already running 2 program in my shipyard, if I have to see how I can meet that date of delivery, what kind of load will be there in my factory, how much capacity I can use for the new program, how much space I will need for material, machine, material and man, key resources, whether they will be over constrained, or then I have to use my suppliers ecosystem to fill up that gap. All those can be done using this virtual shop. So I will showing one example here. So what happened is, from digital twin, I get my engineering BOM. From ERP, I get the material status. But for MBOM, that is manufacturing BOM, you may be calling it palletizations or creating volume creations. So you break the complete structure into small volumes, maybe fabrication volume and assembly volumes. So, but you want to make a track, like what component of engineering BOM got consumed, where it got consumed. If it is changed, you can trace out in MBOM, okay, which particular sub-assembly, manufacturing sub-assembly got changed. So this traceability comes into picture. When your this package has done, you will be creating your steps, manufacturing process, bill of process, where you will define for doing this, what kind of, which drawing, which 3D model, which material, which machine, which man, what are the skill sets of man is required, what tools you will consume, what kind of, so all this detail is packed here. Now, not for every packet, but maybe some complex packet or the heavy packets, you may have to do the process simulate. So process simulate can simulate man, it can simulate machine. So you can see that how I will lift this particular object, take to other position, what kind of time it will require. So all this analysis you can do. If it is a heavy manual labor, as I spoken about the welding posture. So this particular tool also check the stress on human being, the fatigue on human being, and with that you can create very safe processes. If okay, so once this is all done, I will create my manufacturing schedule out of it. Now schedule is ready, all other informations are there. I can load. So yeah, other important thing is the build sequence. We all know that the build sequence is very important. for us. So once this is done, I can load this schedule on my virtual shipyard, and I can run them virtually and see that, okay, what will be my crane utilization? What will be my critical welder utilization? What is the bottleneck? And with this, I can see that at what date I will complete my order. So this complete virtual production can be run. All the bottlenecks can be understand in the advance. So this is the virtual planning piece where we have seen a lot of people are showing interest. Okay. And since you have created so much data, with this data, you can create very easily the electronic work instruction, which can be loaded on tab, and people can use tab, industrial tab in the factory to execute the task. Okay. And again, it is all traceable till digital twin. So suppose if I am, again, that requirement, which is a trigger of change, that can be traced up to any location in this. Okay, whether it has an impact on manufacturing process itself, that change, you can understand that. So probably it will give a way to bargain better with your vessel owner or the contract OEM for the cost of the change. This is one example I just wanted to show you. It is a simple example, like lady and man, they are doing some work. Okay. And this system, our tool, it is helping to find out what kind of load it is coming on his body. So you can see that when he's lifting, he's a tall man, so there is a compression in his spine. Okay. And the same work, now we'll see that it is done by a woman, which is she is of a small woman with less height, and same. So she is not finding any problem. Like, so this way you can find out what kind of percentile or skill, or how to make this thing safe by changing your process. So this kind of insight. So it is just an example to show the capability of the tool which is there. Okay. So once you done your virtual production, the next stage is real production. So here actually the technology which we are going to use is closed loop manufacturing, closed loop quality. There's so many inventory lying here and there that traceability itself is a big task. So we also provide a solution for industrial recognition and identification with RFID scanning. So whether it is metallic or it is other things. So service operation execution, and with on this data, of course, I can run a different type of analytics and on equipment and as well as overall production. Okay. So this is one area I will just try to explain in this slide. So one is your schedule is coming from planning, but when you are executing, you know that there are new constraints appear. The many people who have worked in the workshop, they will they can relate this. Like every time in workshop, we always have a different kind of constraint, and then we have to solve and see that with this constraint, which other activity I can take it forward. So we have a solution for that, which is critical chain based solution. And then now you have an execution plan available. So from planning schedule, you have created your execution plan. So you can load the operation on a manufacturing operation management, which can be used in manufacturing execution. So whether it is man, machine, depending on the requirement and depending on the kind of systems you have, this can be decided, and the kind of information you want to capture right from the human to machine can be planned accordingly. And there is a quality plan which is already published in the operation management. So there will be inspection stages will be there. And once you close, then only depending on what kind of constraint you want to put, like if this all the quality parameters match, then only it should go to the next stage. All those kind of planning can be done here. Okay, and on top of that, we have a manufacturing intelligence engine, which based on the KPI of that particular department, different dashboards can be created to give him the good understanding of the whole operation, which is very important, right? Because it's a so complex environment. In that, we should know that what is our focus area and how we are doing against that. Okay, so these are the solution which we have for real production, and again it is connected to the design. So suppose I have one example I will give. We are parallelly doing two ship. Now the change has come. So with this connectivity, I can find out, okay, I can't change ship one because this is already executed there. So this change is only available for the second ship. Maybe I have to talk to OEM that it is already done, and if you want to execute on both, then I have to rework. And there may be decision, okay, wherever you have done it, leave it, but other ship you can modify. So all this information real time you can capture at the time of taking the change decision. Okay, one example of virtual and real world, this is we have done for Fredship. This is one of our client. So you can see this pipe, they are virtual pipe, and he is standing in the actual structure, because structures have a lot of tolerances because of nature of welding activities. So before bending the pipe, he want to see whether the design pipe will fit inside this, or there is a fouling with the cutouts. So here I am merging both virtual and physical world together by superimposing the virtual pipeline onto a actual this. So this is one. So there is a company called Diota with that. Siemens worked and brought out this solution for that customer. So I thought this is interesting to see how these two worlds are coming together. Okay, so one of the application how you can do this. Now, as I told you, there are a lot of technology which you have used in your actual production. Those can be applied on the real product also. So this analytics can go there. Industrial Internet of Things. So this is common. You can apply industrial Internet of Things on your machine as well as the equipment given by supplier, or the things if you have developed in-house, those can be put together. The supplier will give only this equipment level sensor system. But as a designer or as a design house, I have to give the system level. So you may have to add some more systems on your piping and other things, and you have to give the system level solutions. So these are very applicable here as well. So how it works? Again, you have all your equipment, your ship, on which you will first put the IoT infrastructure, basically connectivity. Okay, and then there will be a data gateway. So all the data will come to here. Some data will go to the cloud from here, and some will come to the edge app, which is on the ship. So you see there are a lot of options available based on the requirement. If it is a defense ship, I don't want to stream my data outside, or I want to segregate that data which is going outside is the non-classified thing, and the rest all I want. So I can create this hub inside on the ship itself. On the machine, on the ship, on the cloud, all the options depending on the KPI. And based on that, different apps will be running, and they will be giving me different insight into my system. Similarly, since I'm collecting the data, so predictive maintenance comes into the picture. So predictive maintenance is very small part of this solution. There is a lot of other values which is coming out of it. So yes, service lifecycle is giving me the value by making sure that I don't replace the parts before its life. So instead of time-bound replacement, I can move to the model which is performance-based replacement. So that will reduce my service cost. Okay, so all these possibilities are there. And this is a scenario I was telling, that pump story, like this pump is not available. So whether I have to, a new pump, if I have to put, I should know the impact of that on the system. So then this all things works together, and using that I can give you the better prediction on this. Okay, so this is a little inside how we process the data. So these are the equipment where various kind of sensors are there. There are many more. These are some representative which is collected over the cloud, and then there are processes like collection. Then we have to prepare that data. Input will be created for further processing. Output will come, which will be there, then it will be stored, and this output will be connected to different plots. So this is the way whole IT twin works. Okay, so with this, basically what we are doing is, this is the engineering twin domain. You can see that it have complete virtual product, virtual factory, virtual production, real production, and then in the real production, you use certain machine, and on your product you have certain equipment where you can use this operational technology, and you can have a information technology layer on top of it. So basically ITA twin. So this is the way this whole holistic twin works. So it has a this kind. So many times people only talk about this operational twin and information twin. But now there are many literatures which is now talking how to bring engineering twin together to especially for the equipments which have a larger life. So you're dealing with the equipments which are there for 30-40 years, and that's why this engineering twin becomes very important for them. So there is one part is I was talking all the Siemens tools coming together, but the systems are not solutions are not limited to that. You just a small example I have given. So at the bottom, today industry state, I have all silo solution, ERP, PLM, maybe manufacturing execution is there, maybe IoT is there, CRM there, customer relationship, or job card, time card, all these things are, but they are at silos level. So we also have a solution called Data Hub, which sits on top of it. And it tried to connect all this information together and try to map all the silo data with each other. Okay. Since all these are connected. So example is event broker. What I can do is in ERP, if I have purchased something, so that status, so this will capture that this event has happened in ERP, and based on it can trigger event into job card, that this particular job is now ready to execute. So all this kind of things we try to achieve using the Data Hub, even if you have a silo solutions. Now this, since you have now more intelligent data, more traceable data, digitalized information, then you have different application running on top of it, different apps, monitoring, alerting, inspection, ticketing, scheduling, audit. So depending on each shipyard, or whether it is dockyard. So this is available for everybody. And then on top of it, we have a layer, we have something called no code or low code development, app development system. It is called Mendix. So you can, like a business owner, he did not have to be programmer, but we have made the skill level we brought down, so that without writing a code, just by drag drop and by business logic, he can create his app, which he can publish for other consumer, and that is the platform independent, because it is HTML5 web-based solutions, so they can be ported on whether Apple platforms or Microsoft platform or Linux platform. So it is available for all. So this is a digitalization. This is Industry 4.0, which talks about bringing things together for the better insight, and this insight will trigger the next level of efficiency in the market. So that is the point I wanted to communicate today. This is one example. Again, I am showing where physical data, how I can use. So this is not a ship industry, just for your technological insight, I'm showing you this. So this is a case where this is my plant simulation. Just physical prototype. Yeah. So in this, I have a complete plant, and I have a IoT based actual plant. Now some accident has happened, and I have to capture that particular time and see that what has happened that day. So I can connect to my actual environment. I can select that from the factory. You select this start time is this and end time is this. So I am selecting a start date. So all the data is there, because in real time that accident has happened and gone. I can't investigate. Here I have an advantage because I can pull that data, now load that data into my virtual environment, and I can put more virtual sensors here to find out that what has exactly happened, so that I can correct those things. So that is one example which I wanted to show you, although it is not for ship industry, but it will give you good insight that similar things we can apply on other critical systems if required. Okay. So one last point, when we say digital twin, it's not that your actual machine is running and the 3D model you will see running parallel. So because See, what happens is when you're doing actual, your constraint boundaries are dynamically captured. If I apply this dynamically captured value on my simulation models, that is my, then it will take computing time. Because if it is CFD related simulations, then solving time, it's a computation costly thing. So there is a concept called reduced order model. What we do is all this simulation, there is a technology. In fact, if you see automation, after that there was machine learning, and now it is called deep learning, which is mainly into neural network. So what we do is from this simulation, we create the very fast model based on the neural network by reducing the model order of model and giving the and calibrating them against the actual data. And once it is proven, now this fast element, they are so fast that they can also be burned inside your embedded chips. It can also go inside your control systems. And that way we are bringing all the knowledge of your engineering twin inside your actual physical model. And it's not very difficult. You might be experiencing these kind of things in your car. If you're taking a river, now cars are there, which is parking assistant. So those are running on neural network. They are burned inside your ECU. And when you are taking reverse or parking it, then it guides. So it's the same technology, and it's a very promising technology which is used in the industry now. So we also have a solution which helps to reduce order modeling capability. So you have a simulation from there, you can create this. And this real-time models have a lot of promising application in our industry, even in control system. So what basically we did in this, from product performance to product development, everything is connected. And this gives me a closed loop. So now because of this, I have more insight into the performance of my product so that my future products will get benefited out of this. Okay. So that's the complete, and this whole platform is scalable, right? If you have tomorrow some new technology, you can very easily accommodate, but because it has a open and scalable environment. So that's the point I wanted to convey. With this, I conclude my presentation, and I'm open for questions.
Yeah, thank you, Mr. Singh. Can you all hear us? Hello?
Yes, sir.
Yeah, so thank you very much. Thank you for the wonderful presentation. And we have a couple of questions. And may go to the first question. It is from Professor Ajit Shenoy. And I mean, nice to digitally connect, sir. And is Mr. Professor Shenoy unmuted? Hello?
Can you hear me now?
Yeah.
Okay. So I think I had a couple of questions, but I'll pose one just now. And the first one was about a reference that Mrs. Singh made to CapEx and OpEx. I think it was in the early stages of the digital design twin. Now, those are important aspects that I think different parts of the supply chain will be interested in. So the main engine manufacturer will be interested, obviously, in minimizing their costs, but maximizing the price that they would sell it to a shipyard. The shipyard would be interested in minimizing the production cost to them, but maximizing the price of the charge to the ship owner or the Navy, and so on and so forth. So my question was really about the sharing of data, because one of the points you made about the womb to tomb was the fact that you share information across the collaborating spectrum. Now, some technical parameters, I think we need very transparent communication, the technical performance criteria. But I just wonder how your system deals with cost data and finance data.
Okay. Thanks for the question. For this CapEx and OpEx, that is one of the example we have given. In that particular case, we were considering the steel structure weight. Okay. and the complexity of the design for producing that. So that was the one parameter which we have taken. But you have rightly said, and I forgot to mention in my presentation, Wärtsilä is a very renowned user of our 1D system. But all their engines are first proven on that 1D platform against all the parameters, not only the capex opex, but even on the technical front. Like one of the example which I have, where we created a model and we plotted the constraint versus wetted area versus the stability. So it all depends what is your main intent to validate, and those constraints can be put as the plotting, and against that all the model will be validated.
Does that answer the question?
Yes, in part it does, but it throws open more questions, and I don't know how much time we have, but I'm happy to come back if there are other people, after other people have had their go.
Okay,
Okay,
now we will go over to another question and then we'll come back to you. The question is from Mr. Ravinder Chadda. Could you please unmute Mr. Chadda? Mr. Chadda, are you there?
Yeah, go ahead.
Yes, it's about your question. Could you please repeat the question once again about the database library?
Yes, it seems to be heavily weighted. The system is wonderful. It was a very interesting presentation because it's a very comprehensive integrated system. My question is that like the speaker before me, that it is heavily weighted on data availability. For small and medium shipyards, is there a possibility, because some of this is not open source, so what happens then? How do we integrate it? How do we imbibe this system in our production if the information, if the data is to be gathered? Because we are a small shipyard, so how do we find this information to integrate into our manufacturing processes?
Sir, data is the base, and in fact, I will tell you other way around, because some companies have reached out to us that we have collected so much data, and these data are sitting in silos, and then they are making sense for that particular department or activities, but how we can leverage them together at the organization level to lock more value out of it. But as you mentioned, yes, the game is basically sitting on data. So first, if data is not there, then really systems cannot create the value for it. So you have to first work out what data you have, what is your KPI. Based on your KPI, what data is required. If it is not available, then probably 6 months you have to put a system in place to capture that data, and then only you will start leveraging value out of it. And as far as you said, the small to business and how to create this kind of investment and leverage ROI out of it, it's quite possible. It's all depend what you want to achieve and what is available, and based on that we'll find out what kind of investment is required to create that infrastructure to capture that data, and then only we can create the value. But yeah, that question is right. So that worry will be there, whether the data which is available to me is sufficient, or I need to create an additional infrastructure to capture more data.
Thank you.
Okay.
Understood.
Thank you. Yeah, thank you, Mr. Singh. And now we have a question from Mr. Carr. It is about interface between data development during manufacturing and operational phase. Could you please unmute Mr. Carr?
Yes. Can you hear me now?
Yes, sir.
Thank you so much. It's really very enlightening, and I would say that this data issue is not new, because I have been in this industry 38 years, and from day one I have been dealing with data. When my boss used to keep a small paper in his back pocket and has to ask something, he used to take out and see himself, and he never showed me what he has actually written. From then on, we have come to this far now. And the issue is this system is really is very promising, and I'm quite sure that this area will develop in a big way in near future. The issue which we face most of the time is the interface level. Now you see, now the remote survey is coming. Suppose now at the design stage, how I would know that how much the remote survey arena will, how it will grow and how it will develop. So which we need to decide now only at the design stage, the manufacturing stage, that how much will be covered by the future way of inspection and survey. And also what you've seen is, as you have seen, that most of the things we have been doing, and we have been doing the silos. And as I've rightly said about the deep learning, which you have seen, is most of the time the problems are what data to be collected, and how much. Then again, the cost effect, because most of the time we are challenged by the question about what about the cost, how much cost we can allocate for data. People generally think that data is an additional component of cost, but which I don't believe personally. But that's the real situation. Now we have to really reduce the data capturing and the data analysis to the minimum extent, so that we don't unnecessarily deal with what is called duplicate data or redundant data, which is of most of the time of no use. So as you rightly said, the deep learning, I think, which is the new area where we can do the neural network analysis and actually see that what data is actually matters in whatever objective is set. Sometimes objective also becomes dynamic. But in the beginning, the hurdle is how to forecast about the cost and how to justify the industry that this is the cost which will really benefit you in the long run. And I personally believe that without data, we cannot go anywhere. We cannot answer any question. But still, this question is posed. And I have seen in the industry, what I believe is poverty is not only by not having money, but not having information, not having the knowledge of our own product, of our own process. Today I do a lot of work. Tomorrow somebody asks, I don't know, I have not captured any data. So these are real poverty. So possibly I've not been able to put the question properly, but this is a real problem which you face. People ask about the cost. I don't know how to answer that.
So I think two things I understood. One is, yes, how to bring the people who are going on field for inspection and get that data. So that technology is very much there, and we all understand with mobile in hand, like how that works, right? So that same technology is possible today to capture data and bring that data inside. And the second thing is the cost. So what I feel is, see, this is a very like big company like Navantia can decide that $5 million they are keeping for the digitalization, but that kind of money is not available for everybody. So what basically we profess here is, you start with the baby steps. You just define whatever data is available with you today. With that, you define your KPI, and we can work together to create further app level thing, a simple app where you can have all this information. So with that confidence, you can bring in more solution and application into the system. So it all depends like where to focus. So first we have to build the confidence in the system, so that you can probably do with your existing data. Okay, just take two data sources and just create an insight into that. That will automatically create more confidence as well as more ideas in your mind to further leverage it. That's my point, like proposal for such scenario.
Thank you, Mr. Singh. Mr. Kar, I think the explanation is satisfactory.
Yes, very much. Thank you very much. Yeah.
Thank you. Now let's go to Dr. Ghosh Roy. He would like to speak. Mr. Ghosh Roy, are you online?
Hello, can you hear me?
Yes, we can hear you. Go ahead.
My question first, that we are talking of shipbuilding. It appears the process or concept you have presented esoteric, and enchanting and should be highly useful for launching a satellite. But is the process eminently suitable shipbuilding? Shipbuilding is a sophisticated industry, no doubt, but processes are simpler. Like hull, it constitutes plated structures, which constitutes 70% of the cost of the ship. You have not touched that subject, that building the hull, how by applying your system will bring down the cost, or by applying your system the cost will go up, I wonder. Could you throw some light on my worries?
Yeah, so sir, the way I understood your worry is with this applying these systems, probably our process is very simple, and if we apply all this, the overall cost will increase. That is the kind of question I understood. Is that correct, sir?
Yeah.
Yeah. Okay. Sir, what we feel is like today, if you go for model testing, okay, maybe for defense.
Please
2
talk
to 3.
about hull construction. The main 70% of the cost is concentrated in the hull. Please dwell in the hull construction.
Hull, sir. Yeah, I got it, sir, that question. So what we are doing, we feel that by applying this technology, you will design better hull surface, which will be less resistant and more stable, and you can and that will result into a lower engine sizing, maybe propeller sizing will be perfect, and with that you will save more cost. So we feel that cost of this because although it's a simple industry, but it's a very costly vessels, right? And if you see the proportion of software versus this cost, then the software footprint will be very small in that case. Okay, and it will give more insight into your design upfront in the beginning of the project itself, at the bid time itself. So we feel that it will bring more insight and the more confidence in your design and not impacting the cost heavily. That is our understanding.
Professor Goshra, if I may interrupt, I think the PLM is effectively used in the construction, the shipbuilding industry. At least I know that the case in Japan. So these yards, what they do is they integrate all the systems together, which helps them to do the construction in such a way that the overall cost can be reduced even up to say 20 to 25%. So it is, in my opinion, the actual cost will not go up because the initial cost maybe for implementing the system is involved, but if you spread over the number of ships being built, that cost is actually minuscule. But the saving will be 20 to 25%. So it's actually good for the shipyards to implement this system.
Dr. Rahim.
Yeah.
Dr. Rahim.
Yes, please go ahead.
Mr. Manoj Singh has not given any concrete results, application results, cost saving and all. He has only dealt with the concept.
Yes.
My concern was whether you are by applying this system, whether I would make the construction of the hull costlier. That is the point mainly. Do you have any results that where you have saved time, saved cost, make things competitive? Technology apart. This is the point. Thank you.
Okay, so Mr. Singh, do you have any data of actual implementation in some of the shipyards? May not be in India, outside India. That way you can show that there is actual saving in cost.
Sir, I'm sharing my screen. Is it available to all?
Yes. Now you can see it, yeah.
Yeah, so actually in same presentation, I had this two thing just for time purpose. I didn't share that. So this is one, this Newport News has given this input to us, they will be saving 15% on their Ford class aircraft carriers by using our technology. And they are quite open in sharing that they are on Siemens technology for their digitalization effort. The second example is this is a small shipyard, Flensburger in Europe. So this is 100% productivity improvement they have experienced. So I have many case studies. I just added two as a backup in my presentation, which I've shared with you also, sir. And so this is some of our customers' experience with our technology.
Thank you, Mr. Singh. Professor Ghoshroy, would that satisfy your question?
Yeah, thank you very much.
Okay, thank you. Now let's go over to Professor Shenoy. He has another question. Initially he sent. Professor Shenoy, could you please repeat the question?
Okay, I had a question about the womb to tomb on energy, but can I come back to the concept of data? Because I think one of the previous speakers actually mentioned that the data is in itself a commodity now. It is a commercial commodity, and it can be capitalized and financially exploited or used. So coming back to what Mr. Singh talked about Wärtsilä, about the engine manufacturer going digital, I just wonder how much of the data can be shared between, say, a manufacturer like Wärtsilä, a shipyard, for example, Flensburger or some other shipyard, a shipping company such as, say, Shipping Corporation or Shell, and a charterer who uses the ship. So what I'm trying to get to is that data is something that can be shared across different segments from the womb to the tomb. So from engine manufacturer through to a shipyard, through to a shipper, and through to a charterer. Now, in a naval sense, these things may not be quite so complicated, but in the commercial world, there are complications. And again, what I wanted to ask Mr. Singh was how much of the data is compartmentalized and used within one sort of part of the supply chain, and how much can be transferred across the supply chain from the manufacturer to, say, the charterer. And I just wonder whether Mr. Singh would be able to share some insight into some of the experiences of the Siemens product.
Yeah, that's a good question, sir. And data is basically opening even the new business model for all the suppliers. So yes, so data is not freely available. So it has to be the way today we are negotiating with our equipment suppliers. Probably now data will also become a part of RFP, and where you have to define this data depending on your needs, that this data I want to capture from the equipment, and you have to work out with those, because then they have to select the right sensor at the right location and give you access to that data, and that will generate extra business for them. Again, whether that data is revealing his IP, then it will be a confidential matter. Then it has to be sorted out between your supplier and you. So there are many transactions happening on data, but security, IP, these are the areas which need to be negotiated. I will tell you one small example of one of our customers. They were telling that they were talking to Kirloskar for supply of some equipment from Kirloskar, and they were wondering that is getting supplied by Kirloskar, and we wanted to insight into that. So Kirloskar said, okay, you want that, I can give you equipment with that capability, but I will charge extra for that. And these people, because they were worried whether I will get it from Kirloskar with that kind of arrangement, but Kirloskar were ready to give that as an extra service and generate more money for their business. So this is an India case which I am talking about. It has happened in India. So because, and again, when as an operator, I may not want a data for all the things. So I have to also, because again, it is cost, right? Then we have to find out, like, For my end objectives, what is important and critical, only those things I will negotiate and get it. Sometime if cost is very high, then we all know it's all business problem basically. If it is very high, probably you need to drop. And so those kind of negotiation at the business level, at the technical level, you have to do. But yes, there are companies who see data as a business and they are ready to share data based on the criticality.
Thank you. That was very clear. And if the chairman allows me, may I ask my second question?
Yeah, sure. Please go ahead.
Okay. So the question is on my screen is the digital twin system capable of evaluating life cycle assessment or sustainability of a product or component within the ship or the ship itself on a womb to tomb basis? And I've said through some sort of energy criterion or some carbon footprint criterion.
Sir, can you elaborate on this? I think I missed.
So one of the big challenges for us in this century is sustainability. So the world is talking about sustainability. One aspect of sustainability in shipping is in cutting down emissions and cutting down the energy that is used and go more towards renewable energy. But there's also a school of thought that says that we need to minimize, how much of the Earth's resources we are using. And so the recycled sort of steel, recycled material comes in. So many cars and many white goods manufacturers and many household items are now going towards the carbon footprint or going towards some energy criterion. So is your Siemens system capable of dealing with and addressing sustainability issues as one aspect of performance?
Sir, on this, we have very good case study, real implementation. I forgot the name of the customer right now. So they have used our technology for managing their energy requirement. And sir, if you mail me on manoj.singh@siemens.com, I will share that case study with you. It's very interesting and point blank on your requirement.
Thank you.
Okay, thank you. Is there any other questions? So if you have no more questions, then thank you, Mr. Manoj Singh, for the wonderful presentation and running us through the various tasks associated with PLM and how to integrate and implement them efficiently. And for the audience, thank you so much for your participation and your wonderful questions. And I hope all the questions were answered satisfactorily. Just a minute. Yeah, sorry, there is one more question. Does it help to have boot operation by integrated owner and yard together? This is from Mr. Georgesman. Could you please put him online?
Yeah, thank you very much. I was not able to put that question in the Q&A.
Yep.
Under these circumstances, like it would really help Indian Navy to have this kind of data of both operating and building the ships themselves. Similarly, if we have owners who are essentially big owners, they run their own shipyard and they create the data from their operations and put them across onto the shipyard. So does this, this scheme help this kind of new business operation to come into being? Am I able to could you understand what I meant? It's more from the business point of view.
Yeah, understood, sir. That's right.
And if I may add, there is one project called the Internet of Ships Open Platform. So there is currently more than 63, 64 companies are taking part in that one: ship owners, shipbuilders, equipment makers, insurers, and a wide range of people. So they have anybody who wants to contribute their data can join this consortium. So they can contribute their data. And of course, they will get some of the analysis results back depending on whatever they contribute and what is the requirement. So such data sharing is already kind of formalized in at least in some parts of the world. In Japan, it is this particular project is ongoing in Japan. So this is just some additional information.
Okay. Thank you. Thanks a lot, Mr. Manoj, for sharing a very good presentation and having a great discussion, especially educating us about digital twin in a very basic and very brief level. So that was great. Thanks a lot for your time. Thanks a lot to Siemens for allowing you to present to the Naval Architecture Group. Thank you. Thanks, Dr. Rahim, for chairing the session. Nobody could be better than you to chair the session here. That has been great. I would also like to thank President INA, Mr. Jaydas Gupta, and Executive Committee of INA for organizing this session. I also thank Manohar Seelam for hosting this on behalf of INA. He's also naval architect, though not a part of executive committee, but he agreed, volunteered to host. Thank you, Manohar. I thank all the members of Naval Architects, all the audience who attended. Hope this would have been a good session. We are attempting to have more sessions, at least one session every month. Such short sessions, single presentation. So please do come up with your requests and suggestions if you have any, and also for any topics which you want to. If anybody from your side want to present, it was great to have senior people like Professor Shenoy, Dr. Ghosh Rai, Mr. Kar, discussing and presenting discussing the session. So please participate more, and we will have many more sessions here. Thank you, everybody, and have a nice weekend ahead. Bye bye.
Thank you.